Hi guys, Dr. V here. So we are going to look at velocity versus time graphs. Before we did position versus time, now we're looking at velocity versus time. So to understand velocity, the thing is with these types of graphs, you're actually calculating the acceleration when you get the slope. So for example, remember that acceleration or your average acceleration is change in velocity over change in time, or VF minus VI over TF minus TI. So you can see how these are this is kind of similar to the velocity, which is average velocity is displacement over time, rise over run. So for velocity versus time graphs, it's velocity over time. So meters per second divided by seconds, which makes the unit for acceleration meters per second squared. So this car right here, you see that I'm letting you know it's moving in a rightwards direction at a constant velocity. Notice how at each position and each second, it's like the same distance in between. So that means that this car is moving at a constant velocity. So you can kind of see it in the velocity versus time chart. Over 5 seconds, he does not change how fast he is going. So you can say he has a constant velocity and a zero acceleration because his velocity is not changing. Remember, acceleration is how your object changes its velocity over time. Now we're going to look at something accelerating. So this is moving right in a rightward direction or a positive direction, and it's changing its velocity over time. So you can see that its velocity is changing, it's increasing its speed, and it's accelerating in a positive direction. So it has a positive acceleration. So looking at these different graphs, velocity versus time, looking at it, the slope reveals what it's doing with its acceleration. So all of these objects have a positive velocity, the ones over here, because its velocities are in the positive section. These objects are moving with a negative velocity, and as you can see that their velocities are just in the negative section on the y-axis. So you can get the slope. Remember that your slope with these equals your acceleration. But how can you tell if something is moving in the positive direction or in a negative direction, or positive velocity versus negative velocity? And how can you tell if something is speeding up or slowing down by looking at a velocity versus time graph? That's the question. So the velocity would be positive whenever the line is in the positive region, like we said. If it's below in the negative section, the negative region, therefore it has a negative velocity. So somebody will know if an object is moving in the positive direction if the line is in the positive region. It can be sloping up or slowing down, it's still going in the same direction. If it is in the negative region, it's moving in the negative. If it's in the negative region, it's moving in the negative direction. It can be, oops, that's ugly. It can be slowing down or speeding up, or it can be sloping up or sloping down. It just depends on the what's going on in the scenario. If a line crosses over the x-axis from the positive to the negative or vice versa, that's when the object is considered changing directions. Changing directions if and when it crosses the x-axis, so going from positive to negative, that's when it changes direction. And also, this is an aside because we're talking about positive and negative. If you have a zero velocity, that means that on your in terms of where your velocity is, it's actually on the 0 line in terms of for the y-axis, which is velocity, and then this is time. So if it's on the 0 line at all at any point like that, that means that it is not moving. It has a 0 velocity. So speeding up versus slowing down. If the line is getting further away from the x-axis, it's speeding up. If it's approaching the x-axis, it is slowing down. So even though, like, for example, this is negative, it's getting more negative. The way to look at it, if the magnitude is getting bigger, like -3 to -9, it's speeding up. Regardless of direction, if it's going away from, the further away you're going from the 0 line of the velocity, that means you're speeding up. The closer you get, you're actually slowing down. So how do you calculate the slope? Like we said, average acceleration is change in velocity over change in time. So you can see that if I were to do, for example, with this one, let's do 3 to 1 seconds. So it'll be 10 minus 10 divided by 3 minus 1, so 0 over 2. It's going to be 0 meters per second squared as my slope. No matter which pair you pick, you're still always going to get the same acceleration. 0, because the velocity is constant. Similarly over here, if you follow the same steps, let's just do from 2 to 0 seconds. So it'll be 20 minus 0 divided by 2 minus 0 would be 10 meters per second for my slope. And it's going to be the same for any numbers, any pairs you pick. So a couple of notes. The steeper the slope, the greater the acceleration. It can be positive or negative. And a straight slope is considered uniform, whether it's speeding up or slowing down. So these are considered uniform here and here. However, how do we interpret a curved slope? So remember that we're still looking at a changing velocity. However, this change in this one and this one, they're not the same. It's not uniform throughout. It is still speeding up or slowing down, but notice it's kind of changing its acceleration based on the slope. And people are wondering, well, how do you calculate the slope of this? To get a more accurate number, you would have to do some calculus, which I'm not going to get the limit of something, or you can kind of create a triangle to kind of get the slope of that, which we're not going to do right now.